Thank you very much. It's nice to have everyone here. Hello, my name is Oreolorun, and as she said, I'm a machine learning slash AI engineer. And right there is my co-speaker, Richard, who is a senior software engineer. So yeah, our topic for today is building a browser agent from scratch. I'm sure everyone knows what an agent is, and so basically, an agent is a software system that can observe the state of the world around it, and then call on tools depending on what the client or the user's instruction is. And we'll be taking the presentation today in two parts. So my part will be more of like a theoretical overview of what we have to do today. So yeah, so what is a browser agent? So a browser agent allows you to uh, it receives an instruction in natural language, observe the state of the world around it, which is essentially the browser, and then it performs a task to completion. So that's what we are going to be showing today. So it's basically a software which allows you to communicate in natural language, and then it goes through everything that it needs to do till the task is completed. So yeah, the recipes we'll show you today, they generalize across different kinds of agents, either a browser agent, a coding agent, a research agent, or a support agent. So whatever you see today would basically apply through any kind of agent that you would be interested in building. So yeah, so basically we say an agent is three things in the trench code. It's a large language model, right? And a large language model with access to a bunch of tools and with an orchestration or scaffolding around that to kind of direct what the agent does. And every agent follows a couple of steps. So it observes the world around it, in our case today, which would be the web browser. It decides what to do based off of, what the user needs and, the tools available to it. And then it acts by calling those tools. It reads the results of the resulting tool call, and then it repeats this process until the particular task is completed. So in this section, I'll be going into the architecture, which is the component parts of an agent and how they are put together. So an agent is basically two minds in working in unison to achieve a single task. So I'd like to make an analogy. If you consider a biological being like a human being, we would say the mind is a planner, and imagine if I would want to pick up the cup on that table. So my mind makes up a plan to stretch forth my hand and grab the cup with my hands, right? So in that case, my mind is the planner and my hand is essentially the executor. So we can bring the analogy back to a software product, which is an agent in this case. So the planner is that thing that, observes the world around it, the state of the software around it. It decides what to do, and then it passes off instructions on what to do based off of the user's instructions to the executor to perform a particular task. And the planner and the executor are then connected by software scaffolding, which is the orchestrator in this case. So taking a closer look at the planner. So the planner does not have access to tools, right? So all it sees is the state of the world around it. So it sees the state of the world around it and it sees what the user wants to do. So the planner then goes on to, decide what the next step is to take at this point. And because, the planner is an LLM and we want to manage the context of what it sees, so we kind of strip down everything that our model sees to only those things that are pertinent to the task at hand. So in this case, the planner sees, of course, the user's original question. It also sees the state of the browser, which is the world in this case. It sees the last three steps, the results of the last three steps that it has already undertaken, a summary of the conversation so that it does have context on the task that it needs to do, and an optional user guidance. So talking about the executor now. So when the planner makes up, the plan on what next to do, it passes that off to the executor. So the executor receives one instruction at a time, and the executor does not have access to, the state of the world or, what the user wants to do. The executor only has access to tools and instructions given to it by the planner. So this way we can keep those two logics separately. So the planner makes up, what the next steps be, and the executor only sees what to do next. So in a way, this helps us to manage context as well. Because in this case, if we were using a two-model approach, we could use a smaller model for the executor because, the context will be smaller since we've narrowed that down using the planner. And for the executor that we will be showing you today, we have about 18 tools. Tools for navigation, for clicking, for extracting links, and the likes. So then comes the orchestrator. So it does the boring work, but to me, it does the most important work really. So we need to orchestrate the communication between the planner and the executor. So the orchestrator is that thing that allows the planner to communicate with the executor and as well as do other things that are pertinent to the operation of our model as well. Some of the things that the orchestrator allows us to do in our case is it runs the loop. So there are a maximum number of steps that we expect for our agent to go through. If it exceeds that number of steps, we expect a termination so that we don't run into an infinite loop. It also caches observation because the browser state is quite expensive to compute. So the orchestrator helps us to cache that observation so that if we need to record the browser state, it's no more computationally expensive. It helps us to trim our history as well so that we manage context and we don't clog our context with too much information and then we go into performance degradation. It helps us to stream events in the sense that, as a user using your agent, you want to know what your agent is doing, what stage it's on. So the orchestrator is that part of the agent that helps us to do all of those things. It also catches failures. So the exceptions are converted into strings that can then be passed back to the planner to refresh the process or correct that step. And it accepts interrupts as well. So if your agent is running too long, you could interrupt that, and that is all facilitated by the orchestrator. So how do these parts speak? I'm sure a lot of us were at the keynote. So it's, Pydantic, basically. We would use a state, a Python object, in order to parse whatever the contents of the web page before we pass it to, say, the planner. Now, the reason for doing that is because, the web page is messy, which is a case where we have different things like CSS, HTML tags, and the likes. So we want to be able to strip down all of the information to only the pertinent things that the planner would need to tell the executor the next step to take. So in our case, we would strip things down to just 4 fields. The URL of the page so that the planner knows where we currently are, the title of the page, the text content, and interactive elements, which are some of the most important things for a web-based agent. So interactive elements like, things that you can click on to navigate the page, forms that you can fill, etc. So after we've passed this to the planner as well, we expect an output. So the output itself, again, would be a Pydantic object. It would be a Python class such that we can easily parse this to facilitate downstream code. So the planner essentially outputs an instruction, which is what the executor would feed on. Reasoning, which is basically the reason for doing this, and a Boolean is complete to let us know if the process is terminated or not, and a field called final answer, which is only set when is complete is true, and parallel instructions if we need to parallelize any of the operations that we need to do. So what we get for free by using Pydantic objects in this particular case is we get auto-validation. Wrong types and bad enums are automatically rejected and the planner is asked to refresh that particular prompt. We get predictable downstream code as well. We can easily parse is complete to know if our agent is done with the instructions, and we get easy to analyze logs. So we can parse each of these fields and put them in a log file so that we can observe what our model is doing to debug, or just to get a sense of how well how well our agents handle the particular task. So yeah, falling back on what I said, schemas are the contract between code and model. So imagine a situation where our planner just outputs a bunch of text, right? For our executor to parse this text, we would be doing things like rejects, we'll be doing things like keyword scans, which would be, computationally not as efficient as if we would return a Python object which we can easily parse. So if you look on the right where a Python object is returned, we can do things like if action is complete, we stop, else we run the next instruction. So that would be easier to do when we return schemas, objects with defined schemas. So the last section I'll be taking will be the section on tools. So tools are the verbs basically. So they are the part of the executor that allows us to perform operations on our web agent. So a couple of tenets to follow when defining tools for agents is ensure they are single purpose, typical to any Python function as well. So a tool should not have more than one use case essentially. So a click tool should do just that, just clicks and that's all. So that maintains that predictability for our planner, for our executor. So they should be named as verbs. So things like extract text or text, not text extractor, so that the planner knows what each tool does and when to use the tool. They should have minimal arguments so that we are not passing too many arguments and the surface of failure is reduced basically. And then the errors need to be messages, so we catch exceptions inside the tool and we return them as descriptive strings, not as exceptions that could potentially crash our agent. They should be located semantically as well, so they should match visible text labels and they should be properly documented, which is very important in the sense of the doc string should be there so that our executor knows which tool to call and how to call them. So today, for web agents, we have about 18 tools. So we have tools for navigation, for interaction, for extraction, for switching between tabs, tab operations, for memory operations like saving our search to memory, etc., for asking for human feedback, and also for utility. So that brings me to the end of this theoretical overview, and I'll be handing over to Richard for the rest of the presentation.
Yeah, thank you. Thank you very much. Yeah, if there are any questions, like they've said earlier, you can just feel free to interrupt also as well, and we can take the questions. I just want to see by show of hands how many people have probably tried to scrape the web before, and yeah, how easy that was. Because we know basically when we are scraping the web, the page structure changes dynamically, right? There are sometimes you've probably used some identifiers or something to know where a particular maybe item on the website is, but next day it changes and it breaks your code, right? But now, if we're going to teach an LLM how to actually interact with the web interface, we have to do something way better than that, right? And I think off the bat, we could say something like, yeah, let's dump all the HTML to the LLM and let it try to figure it out. But we are going to spend a lot of token, and we are going to be limited by the context size also that we have as well, right? So we took quite a different approach to this. And one of the approach, even just sitting back here now, and I just thought about another approach also as well that we could actually have gone also for this. One of the approach basically is having the right, let's just go back a bit. Number one, I think for LLMs, basically having the right tools are very, very important. Your agent is as powerful as your tools. So like I said, for the tools that we have extraction of text, extraction of links, then converting the page to Markdown itself, right? So those tools would help us a lot to actually help the LLM see what exactly is on the web page. But even at that, these are some sort in a way limited, right? And also we could take screenshots, send it to the LLMs and things like that. One of the ways I also thought about while I was just sitting down here could be we extract the links, right, from a web page, right? We extract all the links or all the clickables on a web page. You take a screenshot and you annotate that particular screenshot with all the links. Like say, for example, let me try to use this, please. Just a moment. Sorry. So. Let's see. Okay, thanks. Yeah. Let's see if this works. Okay, yeah, thank you. Thank you. So yeah, I just wanted to demonstrate something. Let's say this is a Google page, right? This is the search bar. This is the search button, right? We could do something like create a dictionary in Python and say, when you extract the links, you annotate this page and call this one, right? Just typical example. And you have various search results here. You annotate this page also as well, you call it 2. You annotate this page also as well, you call it 3. You annotate this page also as well, you call it 4. And you have the reference for each of those links. Say 1 is the search button, right? And you put the link there. 2 is the first search result, and you put the link there. 3 is the other search result, you put the link there. 4 is the other search result, and you put the link there, right? And then you can pass this screenshot to the LLM, and you tell the LLM knows exactly what you want to do. Say, I want to search for XYZ, right? He has the text input tool, or you want to click the first result or the third result here. It sees this screenshot, it annotates it, and it takes the annotated screenshot, and then it says, okay, let's click on number 3, right? And in your code, you have number 3. Number 3 points to this particular link. Then your particular tool can just interact with number 3 and just go ahead to execute it. But also, there are still several limitations also with this approach. But one of the approach that we also took was quite interesting. And instead of just, yeah, thank you. So instead of just extracting the web page or the HTML, converting it to Markdown itself, one thing we also did was pulling down skipping the DOM entirely and pulling down the accessibility tree of the particular web page, right? Then walk down through every node and have context based off that particular node on the accessibility tree. And what we did basically is to embed those. So we use like some sort of local embedding. So for example, you could say something like, I want to log into XYZ, right? But because of the embedding that we have, right, you could pick words like, say, maybe the website use stuff like sign up, sign in, and things like that. Just those nuanced terms that instead of just searching for those exact terms when you extract the HTML and stuff like that. So basically, we just extracted the accessibility tree, enrich every node with context. Okay, this is the context behind this button. This is the context behind this screenshot. This is the context behind this link, and we just did some sort of embedding for that particular accessibility tree, and then we just pass that to the LLM. So anytime we want the LLM to take a particular action, we run through that. Let's say click a particular button or say I want to search for a particular thing, right? We take the entire accessibility tree of that particular page, then we run it through that, we've embedded it, then we do some sort of mini search and return all the relevant links and all the relevant information for that particular bit alongside the screenshots to the LLM. Then the screenshot can then the LLM can then use that to make meaningful decision. And this is on the executor layer. The LLM can then use that to make meaningful decision to, okay, no, this is what I'm going to do next. This is what I'm going to proceed to do next, right? And also it can also use that to kind of, if it made a mistake, it can use that to kind of retrace a step back and try to figure out what the next thing should do. It should do as well. So we are going to be just showing a few demo of what this is capable of doing. And most of this is not production ready code. It's not production ready code, but yeah, it's just to show you the capability of what this can do at the moment. So like I was describing earlier, we have like the simple part where we just walk through the DOM itself, right, and all the interactive elements. And we have the smart part. Basically, we're skipping all the DOM and just accessing the page accessibility tree. I think it's by law these days that every website should actually have like an accessibility layer to it. So basically, having the accessibility layer to it will give us the ability for this LLM to actually just be able to, we can pull the accessibility tree from the website and just use that to guide the LLM to do whatever it needs to do. So like I was saying, we pull the AX tree, we walk and enrich it, then we embed, then we score the intent, then after that we resolve and we act based on that. So the index is cached by URL. The same for every same page we reuse it instead of rebuilding again. Then for example, if we try something like, if we embed and we try to click a link and it's not clickable or it's not doing that particular action, what it does is it kind of self-heals and it re-indexes that particular page, retries, and just returns the top 3 result that it needs to return based on the score intent. So yeah, we have like the cheap version and the clever stuff. So the mental model, when we use this, like we use the cheap version, just walking through the DOM without the accessibility tree, when we know exactly what the button says. But when we want to know what the button means, we use like the smart locator for that. Then for the cheap side, a few milliseconds because we are walking through the DOM. But the other one, because we are using some sort of local embedding, it takes a little bit of time. Then dependencies, no dependencies beyond Playwright and other maybe automation browser tools that you want to use. For this, we have like the sentence transformer, NumPy, and rapid force, so that we can just be able to do like some little cosine similarity search and things like that. The cheap approach is better, or the non-clever approach is better when like the labels are unique and stable. But again, we know that these things change. We are dealing with a website. This thing changes often. But when it's novel and ambiguous, or there's like a label drift, then we use like the smart locator. Then failure mode, when it's a hard miss, this one went to soft miss. Then yeah, let's just go over this. Then it said the next state basically is when a text is hard to read. Basically, we hand the model to we hand it to a markdown. So, for example, there are various kind of things we want to do. It could be, let's read an Aka News article, a Wikipedia blog, Wikipedia blog post. We cannot pass in the entire HTML into to the as context, or you can to the LLM, or we could do something like a summarization task or as well, right? We cannot fit in the entire HTML into, so we kind of strip down all the HTML and just convert everything to Markdown that the LLM can be able to handle and read. So one other thing we added to this is memory. Though this is not the best implementation of memory that we could do in this case, because we just use a simple SQLite database, and not just to make things crazy, so that everything can just run locally on your machine. And one of the reasons for adding memory to this is so that we can, so for example, if you navigated to a website before, say for example, Avix, right? And I say something like, go to Avix and give me the paper on attention is all you need, right? So it goes to that particular stuff, then it clicks on the PDF, right? But because you cannot convert PDF to Markdown, it doesn't have that capability, then it tries the HTML version of it. But next time when you go to avix.com, it knows that, okay, now I can't pass PDF, let me go for the HTML alternative of this. So those are some of the reasons why we add like memory to it and all those specific nuances also as well. Yeah, okay. So basically for our various tiers for memories, basically we have like a sliding window. Only the last 3 steps are passed to the planner, like Ore has already explained before. And majorly we store all our findings in an SQLite table where the agent can just recall and just use that for every other thing that it needs to do. Then we have summaries also as well, where we log, as the session grows, basically, we just collapse most of the previous responses and stuff like that, and just compact it so that we don't go over our token limit in this case. Yeah. So yeah, I just want to do a quick demo of the system, and I don't know if there are any questions so far. We can take that, but yeah. If not, I think we can just go into a quick demo of the system. Okay, no questions so far. Okay, cool. And if you want to just if you want to get the GitHub code and just try it also out yourself, yeah, here's the link to the GitHub repository. And you can just clone the repo. Most of it, yeah, it's run. I'm going to be running this locally with a Qwen 3.6 model running on my machine, but you can connect to any open source. You can connect to any LLM also as well, so it supports that as well. But I'll be using a Qwen 3.6 model to run this locally and just demo this locally. All right, cool. So let's do this. Okay. This is connected to I'm using my local Chrome instance at the moment. So one of the things I added to this as well is I can, for example, if I use this command, let me just zoom this so that it's visible. Okay. So let's start with this. Is a it's a CLI tool. It's much easier to build a CLI tool and just nice interface and UX like that. So I have my settings. I'm using Olama and I'm using the Qwen 3.6 model. And I'm just going to put some settings so that we can just enable some settings like vision to be true, so that I can send screenshots to the LLM at various points. Then I'm going to be using the smart layer also as well, turn out to be true. And yeah, I set up various things like the headless browser. I want to be able to see the interaction on Chrome as it's going as well. And max number of retries, probably concurrent stuff you can run in parallel also at the same time. And one of the stuff we also added to this is it can open multiple tabs for you and just continue to work on tasks on multiple tabs for you as well. Okay, so I think my first task basically for this would be telling it to go to Amazon and search for a book and add it to my cart. So So yeah, it started the planning, and once it starts, then we'll start seeing some of the navigated to Amazon already, and one also from the code. Let me just share the bit of the code as well. How can I increase the size? Sorry. Oh, presentation mode. Okay, cool. Uh-oh. So we keep, you can view the logs also here. It's saved everything that the stuff is doing at this particular point. You'll be able to see the logs. But yeah, let's go back to this as well. So it has navigated to this. Then it's trying to look into, it has found the book already. Now it's trying to add it into the cart. And we can see what it's doing at each step of the way. So it's showing you everything that it's doing. It has found the add to cart link, and it's saying it's going to click it already. So clicked on the book on that. So it has added it to my cart already. So we can try other stuff, like say, I think a good one would be to say, look at the attention is all you need paper. And then yeah, it's going to come up with like the final results here and say, okay, task completed successfully. I've done X, Y, Z, and now it's in your cart. Then if you want to even proceed to buy the stuff, buy the book also as well, you can just tell it to proceed to buy the book also for you as well, and it's going to execute that for you. Then we can go to say Avix and just say, find me, summarize the attention is all you need paper, right? So say go to and then we'll start saying, yeah, that's gone to Avix. Start doing some of the search, and we can see the step that it's taking also as well. Yeah. It has filled it. Attention is all you need. And this is various type of websites that we can also try and just, investigate also and just tell it to do anything that it needs to do. And one of the other things we added also in this browser agent is, for example, if it's stuck, like say captcha or Interbot, it can just ask you that, okay, I'm stuck at this particular level. Can you just resolve the captcha, or can you just resolve the Interbot stuff? And it's going to fix that for you. Yeah. And you're just going to do that, and you're just going to let it know that it's done. So yeah, it's still working. And pending the time while this is still working, I can just go through the code and just explain some of the things that we've talked about theoretically, and we can just show you from the code also as well. Okay, so let's start from the tools. We splitted the tools into various, like Ia said, we have like about 18 tools. There are browser-related tools, and there are other tools as well. Let's start from the smart search. This is basically get the embedding model. This is a local embedding model that we'll probably download from Hugging Face. Then once you get the, this is where we index the browser page. We get the browser, and we are using Pydantic AI here, and there are various dependencies that we've injected into our context when we're starting, which is the browser that we are using, and we can get the page. Then from the page, we get the accessibility tree, and from there we embed the model. We call this page indexer. a function that we built to like just build to get the full accessibility tree and just embed the model, walk through every of the node on the particular page and embed the models and embed the accessibility tree rather. So from there, once that is done, we've built the index. Then we have various tools here like the resolve and act. Basically, what this does is it gets the index from the embedding model that we have. It looks for the intent to what we want to do, because the LLM is going to tell it the intent of what we are trying to achieve, right? And based off of that intent, it's going to search the already indexed accessibility tree. Then when it searches the index of that, searches the index that we've already embedded, then it's going to return the top 5 results. And when it returns the top 5 results, then it's going to send that back to the LLM, back to the planner and say, okay, yeah, for this tool that you've called, this is what I found. These are the buttons you could click. Then it's going to go back to like the interaction, one of the tools on the interaction layer, like say scroll down, click selector, press key, or type text, or click basically. Then it's going to perform that particular action and just handle that. Yeah. All right. Is there anything you want to add to this also as well?
Sure. Yeah. I think this should be almost done. So just based off of the first task that we completed, so I'd just like to show you like parts that are the planner and parts that are the executor in this step. So in this particular step, this right here, these 2 lines would be the planner. Oh, so yeah, summarized our.
Okay, this is done.
Attention is all you need. Yeah. So right here, the first step right here is the planner thinking, observing, the current state of the browser, which is the physical, it's, it's view of the world at that point, to know where exactly on the browser that we are. So after observing, then it passed off, an instruction to the executor to navigate to this web page. So that is just the interaction between the planner and the executor that we can see here. And that is facilitated by the orchestration layer that I mentioned earlier. And the same process is repeated in step 2 and step 3 till we, completed its task in step 4. And we also mentioned that, what the planner sees is a stripped down version of the web page, which is its physical world. And we can see that here if we look at, so we're looking for the executor and agents. So I'll show the planner first. So this is, of course, that's the system prompt for the planner. So the output type is the planner action. So this is essentially what the planner returns to the executor. So instructions, a boolean is complete, final answer, reasoning, and then parallel instructions. And we can see that the planner action, which is the output from the planner, is a Pydantic base model class. So we are stripping down, the instructions that we pass between the planner and the executor to be just things that are pertinent for the operation to proceed and move forward. So, and I think this is the browser state also, which is the first thing that the planner is going to see. Mentioned in the slides that we strip that down to just the URL, the title, the text content on the page, and interactive elements, which are things that you can click on. So using that information, the planner knows what to tell the executor to do at every step. Passing over to you.
Okay. Yeah, let's go over what it has just done on Avix. So let's just go back to this and just confirm that, yeah, it is indeed the attention is all you need paper that it actually pulled out from. And as we can see, it's like the HTML version of this that it read, because definitely cannot process the PDF. So let's go back to some of the steps that it took. Because I had tried this earlier, this same particular stuff earlier, it had brought back from the memory that it's supposed to click on the HTML, not on the PDF, right? So that's why I did not even try to access the PDF at all. So it's these are some of the steps that the browser agent tried to do. various steps that you try to do to complete this particular stuff. And now this is like a detailed summary of what the attention you need paper is all about, and it's returning it here to you also as well. There are various things I've tried with this browser agent. For example, I've told it to send an email. And interestingly, one of my LinkedIn posts that I posted about this, it was done from the browser agent. And I think maybe we can just do another one, simple demo of just saying to post something on LinkedIn about this.
We're currently presenting right now.
Yeah, that we're currently presenting right now. And yeah, tell the browser agent to just undo that and kick that off. Yeah. Okay, so go to LinkedIn and post that I am currently presenting on browser, on building a browser agent at Pydata London. Okay, and yeah, it's going to scoot off and just execute that at the moment. And so let's just take a deep dive into the code while that is executing. So like Ori had mentioned initially, we talk about the browser state. The parallel step here basically is for once you want the, if you want the LLM to do multiple things at once, like open multiple tabs, it keeps track of the tab ID and the instruction that it's supposed to do, because you can tell it to do stuff in parallel and it's just going to execute that for you. Then basically you have the step result. Then we have the executor agent itself here also as well. So we have two agents, like two layers, the planning layer and the execution layer. Then we have, this is the system prompt for the executor. We are telling it access to like the tools that he has, if it needs human help, the tools that it can call out for, and various things like that. Then we create the executor agent. And then, yeah, with the executor system prompt, the agent dependencies, whatever it needs. The dependencies for this agent here is the browser, the memory, and yeah, the display to stream back whatever we need to stream to. Then we have like an input queue. Say there's a follow-up to whatever you want to ask the agent to do while it's currently executing. We're just going to pass that to a queue. Then when that is done, the agent is just going to pick up from that queue and continue to implement based off of that. Then yeah, the page index also as well, like the accessibility tree that we've indexed and embedded as well. Then from there, let's just take a look at the orchestrator, because like this is where the meat of the yeah, that's the most important part of the code basically. So we have like an orchestrator class basically that runs the entire agent. This is like the main thing for the agent. So we define various stuff to like just log simple stuff to log, and so that we can be able to like trace back to what our agent is doing. And we can see from here like various things that the agent is doing, like the logs that we can see, the tool calls, the steps, the output, and various things, the result of the tool calls and things like that. So if you run that on your machine, you will be able to have like a logs folder here that you can be able to see like the output of what the browser agent is doing. So yeah, back to the orchestrator. So yeah, from the main, let's just look at this run task function. It takes in the task and the session, the browser session itself. Then what it's going to look at is, at first, before we even try to execute anything, it's going to look at like the total length and the maximum memory length that we've set it to be, like for the entire conversation. Then if it's exceeding that, we are just going to try to summarize all the previous conversation and then compact it before sending it to, before attaching that also to the LLM to be able to do whatever it needs to do, right? Then we start with our conversation context. We inject all the necessary dependencies that we need for this particular for this agent here, like the dependencies. Then if there are any user guidance, like say, okay, this is what it needs to do, like maybe you asked a follow-up, added a follow-up call to it or something like that, then it's going to be passed as the user guidance here. Then now, this is the loop where the agent starts working. We set like, you can decide to set your own maximum number of steps for the agents to work, right? And after X number of steps, the agent terminates and says, okay, I'm not able to find this particular stuff, or I can't do this particular task. Let me see if this has posted something on my LinkedIn. Just a moment. So please just let me check. Okay, it hasn't yet. Okay, let me see where this is at. Okay, so it says it's unable to click a particular button. Uh-oh, it got stuck. It's trying to change who can see my post. Okay.
Just click on done.
Let's do done. Okay, it has typed, I'm currently presenting my talk at this. So I can just tell it I'm done, and it's going to continue again. Yep. Okay, let me go back to what I was talking about. Yeah. And this is basically, from here, it's the loop that checks the number of times, the number of steps that we should run for our agent. And if you look at this, okay, yeah, this is done at the moment, but I'll get back to this. If you look at this, when we started, it says something, or let me just type settings here. It says max steps 15, right? That's the total number of steps I can take for number of iterations that the LLM can do various stuff before, number of steps it can take before it then terminates and not and say it can't particularly solve a particular problem. But if it does that before then it's fine. Like for this now, it says it completed this in 4 steps, right? So we have to kind of define like how long we want the agents to keep running, and we can also even set terminal points also in our prompt or various things. But I think it's better to just kind of set it up in your code, because that way you know it's guaranteed and it will not just keep running as much as possible as such. Then one of the things we do is we try to see get the cached state cache for this particular browser session. We try to look at the history, like, okay, it's a new prompt. If there are various histories that are in the that we have already about what we are doing, like the tasks we are doing also as well, that can help and give us context for the LLM to continue to do what it does. Yeah. Then from here, we then format the planner prompt, and this takes in like the browser state, what we have in our browser state here, like the URL, the title, the text content that we've extracted, and if there are any interactive elements also as well, right? And the conversation context, the recent history, and then we look, we append the previous conversation on the task that it has been told to do before, right? We attach the original task that was there. Previous conversation around what it's supposed to do, the URL, the page content, the title, and the interactive elements. If there are any recent histories, we add like the previous step that it has done, and whether it was a success or a failure, and what it should like, so that it would know what to try next, and not just keep trying the same thing over and over, right? So if the previous step was like a success, then it knows that, okay, it's to move forward with what it's doing and not just retry that previous step also as well. And then if there is a user guidance that it needs to follow, then it just follows the particular user guidance. Then this is on the planner layer, and this acts then because it's like a back and forth between the planner and the executor, right? So it's now asks here, what should the executor do next, right? So we've given it all this context. It's now saying, what should the executor do next in this case? Then the planner then is now going to return back to the executor and say, okay, this is the list of things you should do based off the prompt that we've just defined here as well. Then yeah, we can capture screenshots for this particular for what we are doing, so that we can just attach the screenshot to the LLM, and it can have context and have visibility into what we are doing at the moment. Then we run the planner. Once the planner is done running, if there are any, if there we have two queues basically, one for the planner, and one for when the planner is running, and one for when the executor is running. So we can just try to drain the queue also as well once it's done, so that it can continue. So once the action is complete, then we can now. Do you want to step in to just continue this? Yeah. Sure. Yeah.
So once the action is complete, then we can display, what, the planner result is. And then, of course, a critical step, we log what we have just done. So at this point is where we check if the final answer, and or we default to task completed. So if we have set a logger, of course, we would log our step right here. And if there are any parallel instructions, then we undertake those parallel instructions. Again, critical, we always display our results to the user. That's, what you see here on the CLI. So the display function, the display method right here, the show planner results, is what shows that on the CLI. Then we wait for our, parallel execution, and then of course, we continue the process over and over until we get to a terminal point, which is task completed, essentially. So do you want to talk about the LinkedIn post?
Okay, yeah, let's just go back to the LinkedIn post, and so that we can just see that it has posted the, that's interesting. I guess it didn't post it.
So yeah, sometimes these things can be a bit funny, but the ability to observe the web and to to navigate pages, that is the agent itself.
Yep. Okay. So yeah, let's just go back into understanding what the code is, and if there are any questions, also like we said, let's feel free to just interrupt, and we can just take questions as well on that. Then important thing to note here is once we're done with a particular task, is we kind of add that to the history, so that it can just keep going and kind of invalidate some of the cache that we have also as well. And there is a particular setting here. I think if we look at this particular bit here, set vision to true, and that's when, if you want to use screenshot and whatever we are doing, and just send it to the LLM back to undo that. Then if we set this to true, we kind of add that to whatever we pass on to the LLM to be able to do. Then like I said, if we get to the maximum number of steps that we should get to, that it got to without completing the task, then this is like the answer that we're going to get, right? Because we set a limit that within this particular limit, the LLM has to undo this particular attacks and just get it done. Then there are some interesting stuff that we also put to undo stuff like cookie pop-ups and cookie pop-ups and like various things like that would stop us from handling the from accessing the page, or probably doing any other activity on the page, like scrolling and interacting with any other links in the page. So we set up some stuff like patterns, like timeout, overlay. Like if the element is not visible, then you should try to kind of undo like the cookie pop-ups and just try to click maybe accept all or reject all, and things like that. But whatever, when it's stuck generally, and it cannot be able to undo that particular bit, it then comes back to the user and say, okay, I'm stuck at this particular position, and the user should probably interact with the stuff on the website and so that the LLM can just continue, the agent can just do what it's continue the task that it's doing, so, and just unblock the agent from doing what it's supposed to do. So I think that's most of this bit for the orchestrator part. The remaining part of this function is just streaming to the UI. That's the CLI tool, to be able to just see what our result is at each point in time, like the streaming executor. Like we said, the major part of this, of building this browser agent, is the tools, knowing what tools to build, especially when, and that's why we said like it's something that you can also extend to other kind of agents that you build, whether a research agent, but knowing what kind of tools to build, and basically the orchestrator layer also as well, how the planner and executor kind of interact with one another. And yeah, basically, I think, yeah, that should be. Anything else you want to add?
Yeah, just a quick note about logs. So the logs are not just, I mean, obviously in the development process, telemetry and logs. So those allow us to see what our system is doing behind the scenes. But logs can also be, beyond debugging. They could also be important when you want to optimize the system or when you want to know why, your task took maybe 10 steps instead of 5. You could look at the logs to see what tools were called, at what point is your LLM making mistakes. Maybe that would inform you to switch to another LLM provider to get better results. So the logs are, for me, a critical part of building this tool because it allows us to see what we're doing and how we can optimize the process that the LLM itself is following. So, yeah.
Yeah, any questions?
Any
I
questions?
think that will be it from us. Okay.
Just one question.
So it looks like it uses your sort of browser with your kind of current session.
Yeah.
Do you have any thoughts on what a good way to box that off would be? Like, say I'm happy for it to buy things on Amazon, but I'm not happy for it to log into my bank.
Okay, I think for what I did, basically, I actually ran this command first. Connect. So basically, what this does, that's what I did in this demo. What this does is basically it copies all my my Chrome instance into a separate Chrome instance that I can just run with this and just do that. But if you don't want to do that, you don't need to run this connect command. And the reason why I did that is because I wanted to do a demo on Amazon so that I can just, instead of having me to log in and do all those kind of things, it's already logged in on my Amazon, copied my Chrome instance and things like that. When I want to post on LinkedIn, I don't have to re-log in again. It has the login details for that as well. But if you don't want to do any of that, don't want it to have any access to your system, it's also possible as well. Yeah.
Yeah.
Yes, please.
This seems really useful for performing actions in the browser. And I was wondering about its applicability to web scraping and extraction, because I asked, could you create a CSV file, right? And it said, well, here's your formatted sort of tab delimited output. You go paste it into a CSV file yourself.
Yeah. Okay, yeah, that's another thing. So for example, for that kind of task that you just talked about, you could actually add a tool for that, extend the functionality, add a tool that when you get a result or something, like you can now write into a CSV file. You could call the name of the function write to CSV. So whenever it says, okay, I want you to do XYZ for me and write the result to a CSV, then it knows to call that particular tool. So that's why I said initially that your agent is only as good as the number of as the tools that you actually input into it. So anytime you see probably like there's some sort of limitation with this particular agent, can I extend the functionality by adding a tool? Or even better, right? What we do these days is add a skill, right? There's you could build a system to support a skill. Even what we've done so far, we could extend it also as well. Instead of just adding a tool to this, we can just add a skill also to it, like CSV writer skill or something like that. Yeah.
And also to add to that, we are already doing something similar to web scraping in the process itself when we get the browser state. So like he said, if you put a tool in there, it will be easy because it just goes off of the browser state to get the content of the page and then saves it however you want to save it.
Yeah.
Nice, thanks. I'm sure there are more questions, but I have a tip. If you're using Olama, you've just installed it, and you're getting this error about how like it's exceeded its context window or whatever, you have to go into settings and scroll down and increase the context length if you want to run the local model successfully.
Yeah.
Is that a long question?
Yeah.
Any other questions?
Any other questions?
If I may also ask for question like, yeah, Richard, for your first example, you prompted the web agent to go to Amazon and search the book and put them into a basket. Is it something also considering for agent ask back question to you? For example, what if there is a second edition, third edition? Agent might get confused which edition you are looking for. How about Audible, or which types of the book you'd like to get? Is it something you are considering to develop further?
Well, yeah, it's something we could also add. Basically, like if we, I think there is something here. Okay, I think there was something I tried previously when I said it should try to order the book for me, right? It came back to me and asked, is it the paperback or the hardcover, right? Because there are two prices for that. So he was asking, is it the paperback version I wanted or the hardcover? So from the two, we also added, yeah, but it's something that we could also improve on, like you mentioned, like instead of the agent assuming, we can always tell it to be explicit in our prompt and say, look, if you are faced with any kind of decision, reach back to the human for an answer if you're unsure about anything. But for what we for one of the things we added, one of the tools that we added here is the Ask Human tools, so that it can, if it's kind of unsure about something, it can always ask you. And also, for example, if you want to, one of the things I also tried when I was building this was, if I want to log into a particular page, right? It can go on that particular page and ask me to fill the form and say, okay, I want to fill a particular form. It doesn't have the details for those forms. It comes back to ask me, okay, I need to fill this particular form. Give me the details of what I need to fix. And I'll input the details and it just goes ahead to just do it. Yeah.
Also, to add context to that, if we were building an e-commerce agent, yes, we can also like consider things like that. So particularly agents that will be interacting with things like credit cards or financial information, we would really lean on the human in the loop aspect of the agent, such that the agent comes back to ask for authorization or verification before it carries out tasks. So yeah, if we were specifically going to tailor this towards e-commerce, like buying things on Amazon or paying for, food or whatever, we would lean heavily on the human in the loop so that the agent comes back to us to ask for verification before things are executed. Yeah.
Thank you. Any other questions?
Any other questions?
Okay. Okay, yeah. Okay, you want to take that?
Yeah, so we would essentially checkpoint certain operations. Like for instance, if you go back to the Amazon example, if we want to purchase something on Amazon and we want it to do this end to end, search for the product, search for a particular version, and then pay for that said product. So we'll be checkpointing at the point where it searches for the product. We ask it to come back to us to ask for a version or a type. We checkpoint, adding it to the basket as well. Would you like to add this to your basket? And then we checkpoint paying for the product itself. So it's not so much a thing about, confidence of, oh, can I proceed? It's a thing of knowing when to stop and, come back to the user for verification or authorization before you can continue.
So maybe just to add on that also as well, we could add something like in the planner layer, right? Some sort of mini call to an LLM to classify the kind of task that the person wants to do. Is it a task that needs an action of an human, or that the executor is supposed to do? Is this something that needs an human intervention or something that does not need an human intervention? So a simple layer just to classify that kind of task also can be something that you can also add in there as well. And you can also, like, you can put it in your prompt, in the initial planner prompt also as well, but you can also add some sort of safeguarding as well, and coupled with the checkpointing that you mentioned, you can also kind of add a simple layer of LLM to just classify those kind of tasks, so that, yeah, we don't miss those kind of things here. And also, I think one of the things that we kind of forgot to mention, especially when building an agent, is taking time to evaluate the agent also as well, running evals and on various part of the agents basically, so that it's actually doing what it's supposed to do. Okay, yeah, there's a question.
Are you okay to talk about like applications or what you're looking to apply this technology to, where you're looking to go with this next?
Well, basically, I think for me, this is just something to show that, yeah, this is possible. This is what can be done with this. What we can do with an agent. So, for example, you could also include it in maybe something like your daily driver, something that you do in your, like, probably your daily tasks or something like that. Or you don't want to fill XYZ form, and I have all these things. Just handle these tasks for me. For example, like I said, I use this to respond to emails. Sometimes, so I don't just want to write emails, or maybe I want to post something on LinkedIn or something on X. Like, just undo that for me and just kind of do this thing. So I just see it for me as like a convenience tool that I can use. Yeah.
Yeah, that sounds great, because the summarization you kind of get through other means perhaps, but like the action is, I think, the really outstanding piece.
Yeah. Okay. Anything you want to add?
No, I think, yeah, that would be all from me.
I think, yeah. Okay, yeah, there's one question. There is one question over there.
Sorry, very procedural question, but I joined slightly late. Do you guys have a repo link or QR code or something?
Yes.
Sorry about that.
Yeah, this.
Nice. Okay. Thank you.
So yeah, it's open source. If anybody wants to add anything also to it, yeah, feel free.
Yeah, and if you want to clone it and do your own thing on it, that's fine as well.
Yeah. Yes, please. Sir. Yeah.
I just had a question regarding, like, on many of the websites you get captchas. Hi. Thanks. In many of the websites you get captchas and like ways to prevent bot access. So how does your system overcome that?
Okay, so at the moment we do not we've not incorporated the captcha solving bit to it, but there are ways you could also extend that. So you could extend that with a tool also, and there are also other captcha solving services that someone could incorporate and just use that to solve the captcha basically, because some of these captchas are kind of very rigorous, that even you solving it as a human being sometimes get confused, right? Not to talk about an LLM, right? But there are some, like, say for example, press and hold, right? It could be something that you could extend the functionality into this system that will be able to solve that captcha. For example, previously when I was building some sort of browser automation system, I had issues with closing pop-ups, right? But with this has no issue closing any pop-up or accepting cookies or rejecting cookies. But the next phase of work for this would probably be captcha. But aside from even extending it as a tool, there are other things that someone could actually do to kind of prevent all this kind of capture stuff. Like, for example, there's something called browser fingerprinting, right? Looks at the rate at which you click a particular stuff. Do you have extensions, Chrome extensions on your browser? Like, what's the browser agent? Like things like that that someone can actually use to kind of prevent all those stuff without even going into the main capture solving side. Yeah.
Okay.